Well, good afternoon, everybody. This is Dave Jones with Storm Center Communications and GeoCollaborate. It's Wednesday, November 20th, 2024. This is an update for the All Hazards Consortium, Sensitive Information Sharing Environment, where we share information across platforms from private sector operators in the private sector to private sector liaisons working for state emergency operations centers and also some other agencies. You can see what's going on here in the Pacific. This is not the Atlantic, and it is not a tropical update. We have a major storm system that bottomed out yesterday, really dove down with the pressure. We call it a bomb cyclone or bombogenesis. That's what meteorologists call it, and I am one of those. But we have had a significant atmospheric river really coming into California and Oregon. So I have a number of things that I want to show. Hopefully it will all work out here. You can see in the satellite imagery, this is the GOES West satellite. The GOES West stationed over about 135 degrees west and the equator. And it orbits at the same speed as the Earth rotates. So it keeps looking at the exact same place on Earth. Geostationary is what it's called. You can see that top spinning here, very large waves being reported. I'll try to show you some of the buoys out there, 16 to 20 foot waves, in some cases even higher. But this is the atmospheric river. This is it. This is what we call it because it transports a lot of moisture from the Pacific in this stream, almost like a fire hose, into the West Coast. And that's not just it. When that air hits the mountains and gets forced up, it rises and enhances the precipitation. And so it's really important to let Western water operators, dam operators, reservoir operators know about how much rain is coming in certain areas so they know whether to release water from the reservoir or to hold on to it because it won't be enough water to overflow. It's a very delicate balance of water management, and this is why we pay so much attention to these atmospheric rivers. Plus, they can be devastating. You get too much water in a location, you get mud flows, debris flows, lots of floods, and really hampers the movement of anybody around cities and towns. So this is what we have. We have this low pressure system. It's pumping in this moisture into California and into Oregon. And I can show you the weather radar as well. I'll do that right after I show you the upper level moisture in this GOES satellite image. So you can see it spinning around. I'm going to turn on the moisture channel. And you can see this even better. Look at all this moisture. Any of the white areas that you see here, that's a higher concentration of moisture. The darker areas are drier air. And then here is that atmospheric river. Look at that. Can move out over here. Look at that. It's wide here, but it kind of funnels right in almost like a hose, dumping right into California. This has been moving slightly to the south during the day, and right on the doorstep of San Francisco Bay, just to the north, we have heavy rain falling. And that data is showing in GeoCollaborate as well. I can show you GeoCollaborate right after I take this full screen. You can see what's going on. Look at this trough in the Midwest. That is ushering in very cold air. Big change in the weather coming on the East Coast. I'll get to that in just a minute. But over here on the West Coast, we do have all of this moisture headed our way. Now let's go over to GeoCollaborate, and I can show you what that looks like. Here's GeoCollaborate, and I'll move it over here to California. The stream of moisture, you don't see all the rain out here because the land-based radars do not reach out very far in the Pacific Ocean. And also some areas, mountains block the radar beam. But you can see that moisture coming in. Here's San Francisco right here, streaming right in from the ocean over Santa Rosa, Sacramento, up to Chico. This is where the Paradise Fire happened a number of years ago. So there's a lot of burn scars in this area. So there's likely to be some mud flows and debris flows happening there. Now I'll back out just a little bit so you can see in Northern California, here comes this batch of precipitation. Also into Southern Oregon, Medford, and the coastal areas. Now, I do want to show you this picture. This is a live webcam from Crater Lake in Oregon. And this is the Steel Information Center at the park headquarters. They're about 6,500 or 6,450 feet in elevation. And it is really coming down there as far as snow is concerned. I have some statistics that I want to show you as well. The depth as of yesterday was 54 inches of snow. 54 inches. Their average depth at this time is 17 inches. And it looks like they could get upwards of another 43 inches of snow by Saturday. The most recent 24-hour snowfall, which was yesterday, was 9.7 inches. They could get another 24 inches today and then more into Friday and Saturday, totaling up to about another 43 inches. But look at this. Look at the average annual snowfall, 533 inches at Crater Lake at this location. That's 45 feet of snow, if you can believe it. The greatest seasonal accumulation, 834 inches in the winter of 32-33. That's 1932 and 1933. The greatest recorded snow depth in April 1983. How much was on the ground at one particular point in time? 252 inches. Now, snowfall is on the decrease as time goes on, and temperatures are on the increase. And so meteorologists and climate scientists expect that trend to continue. But wow, that's really amazing. Let's take a look at just that picture on its own. Visibility is tough. I'll tell you, if they get, 500 inches, you won't even be able to see that lodge. It'll be totally buried. But they are continuing to plow it. And I did see a car there a little bit earlier, about a half an hour ago. So there is a four-wheel drive that's able to maneuver itself. And while I have GeoCollaborate up, we might as well check a few of these wind speeds. The storm is way off the coast here, but still some big winds and also some big waves. Look at this wind right here. Southeasterly wind, 33 knots, gusting to 42.8, almost 43 knots. That's well into tropical storm range. And if I move up towards Seattle, look at this, winds gusting to 29.2 and air temperature 48. Not a pleasant day there. Here's some winds gusting to 35 knots, and look at these wave heights. 29.2 foot waves. So it is cranking there. And even you folks in Vancouver, you're seeing rainy skies and windy conditions, but certainly not as strong as they were experiencing just down to the south. Here's a buoy from the Environment and Climate Change Canada. 29.2 is the wind gust there in the sound. And this is Vancouver Island right here. You can see this buoy here, winds gusting to 35 knots. So we're definitely getting, it's a windy day. It's a nasty day out here in the ocean. We also have some pretty big waves. Look at this. 25.6 foot waves out here in the Pacific. Winds gusting to 45 knots. That's into storm force. And that's why we have storm warnings and hurricane force warnings that were in effect along the West Coast yesterday into today. Now, if I go down the coast here towards California, there are some other buoys out here too. This station 46027, 23 knot winds, and doesn't look like they have any wave height measurements. No recent data from there. By the way, there was a buoy out here. I think it was 46005 yesterday. I think that might be this one. Yeah. No recent data because the storm knocked it out yesterday. There were, I believe, 30-foot waves and the winds were howling 60 miles per hour. And the buoy just said, you know what? I'm done. And it's not reporting any more data. So that's why these buoys need to be maintained and why we need all these coastal observations. It's critical. Just south of San Francisco, no data there. Let's see, a little bit closer. There's pressure is falling at that location. And here's a 16.7 foot wave height. So needless to say, the weather is terrible. And I also want to show you the radar data. Here it is. Now, this is a very interesting product This MRMS, it comes from the National Severe Storms Lab in Oklahoma. It takes surface and upper air observations. It takes radar data, lightning detection, satellite observations, forecast models, and it's used for hail, wind, tornado, QPF estimates, quantitative precipitation estimates, and also convection, icing, and some turbulence diagnostics as well. So when we use this radar data, and I may be using this more frequently now, we know that there's a lot of sources coming in to this product. Let's take a look now at the atmospheric river forecast, and I'm not going to spend a whole lot of time on this, but I want to show you what modeling is happening up and down the coast. And what you see here, here's my cursor, you see these dots? These are all locations where atmospheric river intensities are given when one is in the forecast. And when you see the colors ramp up to orange, you can see that orange is an AR4 and red is an AR5. Don't see any AR5s in this particular model. This is the U.S. national model, the GEFS, showing this. I'm not going to show the other models because I just want you to show what we can pull up. Now, I can move with my cursor. See this little ball that's blue? I can move it up and down the coast of Oregon. And so when you see this little ball and you see that it's blue, that means an AR1. And notice, we had one in the past. We had one that just finished in this part of Oregon, just south of Portland and Astoria. And there's another one in the forecast here. Now, this forecast time period is at about 7 o'clock in the morning East Coast time on the 22nd. So today is the 21st, or the 20th, Wednesday. So this is on Friday morning. It looks like we have another chance of a weak to perhaps moderate atmospheric river at this location in Oregon. And so I'm going to move down the coast here to southern Oregon and show you what we have here as well. So this is about the central southern Oregon coast. I would say in some areas, let's see, just north of Brookings and Gold Beach, I'd say around Coos Bay and Bandon in Oregon. It looks like we have the same thing. We had a green AR2, an AR1 just passed, and this is the forecast period again. So another not major, but kind of a minor atmospheric river. And so if I move down here to the south, you can see there are yellows, oranges, and then it goes back down to blue. Now, there's some more yellow down here in Southern California because there's forecast to be another system, not as strong as this one we have or the one that's going to develop tomorrow into Friday, but we have another one that's going to impact Southern California. And I want to show you that from the standpoint of the model viewer. And what does that look like? So I'm going to take a look here. I'm going to change this to the CW3E model. This is called the West Wharf model. And I'm going to put this into motion and show you how this system is moving. Now, I've set the time for about current. This is about right now. We have this intense low pressure system. You can see the atmospheric river coming into Northern California. And if I put it into motion here, you'll see that atmospheric river continues in Northern California. Here comes that secondary low pressure system that's going to develop at the bottom of this trough, and it's going to take over as a major cyclone that's going to bomb out as well, at least as far as the models are concerned. Now look, this atmospheric river continues. There's a little bit of a break, and then it redevelops, and this system really intensifies and merges right into that atmospheric river. Look at these two spinning around each other. This is called the Fujiwara effect, where two intense low pressure systems rotate around a common point. It's a Fujiwara effect, and you don't see that a whole lot, especially with intense cyclones here in the Pacific Northwest, but you usually do get it when you have intense cyclones close to each other. So you see this atmospheric river coming into California again as this system bottoms out, bombs out, moves inland over Vancouver. So you're going to get windy again in Vancouver. The next 4 to 5 days are going to be very unsettled. Lots of rain, then periods of just wind and no rain, and then very strong winds. So I would prepare for that. I'm sure you're used to it over the course of the last many, many years in the Pacific Northwest. But see, this atmospheric river continues, and the time here is at 1 UTC on the 23rd. So that is in 2 days. So Friday night, it's about Friday night, about 11 o'clock at night or so, 8 o'clock at night. We're still going to be East Coast time. We're still going to be under the influence of this atmospheric river. But then look what happens. Another low pressure system develops at the base of this trough and approaches Southern California. And it does give some intense rainfall. But look, here's a little atmospheric river that develops. And that's why that yellow dot was around Southern California there for a potential atmospheric river. Now, it may be more beneficial, this one, in Southern California. The ground has been so dry, so it's not going to do a whole lot in the way of flooding. But it will cause quite a bit of rain activity. And so we'll be monitoring that one as well. But that's a third low pressure system that is going to form and move inland. And look at that. This system is still there, and it's just kind of going to spin around, give some unsettled weather, and then finally move inland into California as a low pressure system. High pressure will then take over a little bit and dry things out. But I'm just going to do this one more time. I'm going to do this and I'm going to hold the cursor down. I'm going to hold this down and take you through. I'll take you right up to about now. Our time is about 21Z. So I'll take that. This is about right now. And I'm just going to hold it down so you can see the flow in the atmosphere and this atmospheric river. I'll keep my cursor right here on Northern California. So here we go. There's 1, 2, and then the third one comes in. So that's what we have to deal with over the next several days. Now, I also want to show you something cool from a satellite imagery standpoint along the West Coast. And that's going to be here. You see the moisture coming into the West Coast, but I want to take off the moisture channel and I want to turn on the visible channel. And you can see the clouds, the wind, the moisture coming into the mountains right here. I'm going to zoom in a little bit and let this load up. And so what's going on? Well, you can see the wind and the moisture hitting the mountains. It's going up and over the mountains. You can almost see it rising up and going down over the mountains. When the clouds and moisture hit the mountain, it condenses into heavy rain. On the other side of the mountain, the wind goes down and it dries out. So the clouds disappear. And you can see that right here. This is like a wall of clouds pouring over the mountain, but then disappearing. Happens all the time. But look at this. We get this cloud forming here. This is called a lenticular cloud. It's a standing wave cloud, and you can see more of them up here too, up around Lake Tahoe. Look at all these wave clouds that are just in one location. Now, how in the world does that happen? I have a diagram for you. So this is what it looks like. When wind hits the mountain, it condenses and the moisture comes down on the windward side of the mountain. But on the leeward side, the downwind side, you get waves forming in the atmosphere. And when the wind goes up in those waves, you form clouds. When it goes down, you dry the clouds out and it becomes clear. So that's why you get these type of clouds right here. Look at that. And this one, oh boy, where is that? That That's south of Reno and Tahoe. So this is Mono City is right here. So if you live anywhere near Mono City, you can get out there and take a picture of this beautiful lenticular cloud and other ones as well. Look at these small ones. Even if you go up towards the northwest along the California border, Bridgeport, Sonora Junction, Walker, Colville, you can see these beautiful lenticular clouds. So it's not anything happening. No planes are flying into it. Nobody's treating these clouds or anything like that. This is Mother Nature at its best, creating these wave clouds. And look, they're forming again out here. They're just stretched out a little bit further as those waves kind of dampen out when you go further to the east. See, there's not as many waves. Close to the mountains, you get it. And you can get quite a bit of turbulence, too, when you're flying in this area. You can see quite a bit of turbulence. Roll vortexes happen. Oh, I experienced one of those flying into Hayden Airport at Steamboat about 15 years ago. That was not fun. But you can see all that moisture flowing in, going up the mountain, and then over. And when it comes down, it just disappears. So that is really spectacular. I did forget a couple of things here that I do want to point out because we do have quite a bit of power outages reported in the Pacific Northwest. And that is out towards Seattle. So 485,000 people out of power, or I should say meters are out. Their customers are out of power. Many locations have more than one person here. So I would likely say more than 1 million people are experiencing power outages because of this strong system. And this is just round one. We're going to have another round during the day on Friday as this system really develops on the southern part of this other low pressure system. The power companies out there are saying this is a multi-day outage. Please expect a multi-day outage because of this terrible weather, strong winds going on. As a tree fell right over a municipal bus in the Seattle area. Nobody was hurt, thank goodness, but a lot of things going on as far as that's concerned. And so that's what I wanted to talk about, this tropical update and this update for the Pacific Northwest storm. Now, I'm going to shift quickly over to the East Coast because we have a couple of things that I want to point out on the East Coast as well. So this is the very tip of the GOES East satellite. I'll bring it back here and show you what's going on. I'll take it full screen so we can talk about what's happening. You can see along the East Coast there is quite a bit of cloudiness, but this is what I want to talk about, this particular frontal system. And this is approaching western North Carolina. So in just about 2 hours, this system is going to pass through Asheville and the mountains of western Virginia and West Virginia, western South Carolina, eastern Tennessee. And there's strong winds behind this system. There are wind advisories that have been issued along the East Coast. And that is in the area of Asheville and up and down the mountain chain there, western North Carolina. Now, the real concern is that Hurricane and Tropical Storm Helene impacted them greatly when it came through there, and many trees were upended and uprooted. And then also a lot of trees were damaged. So when this front comes through, we could have wind gusts of 45 miles per hour in this area, which is going to cause trees to perhaps break that have been weakened or other trees to fall over. So there might be some power outages along the Appalachians here in western North Carolina, southwestern Virginia, parts of West Virginia. And on top of that, the air is cold enough behind here, we're going to see snow. We're going to see snow accumulating, in some cases up to a foot of snow in the mountains of West Virginia, maybe 4, 5, 6 inches in western Maryland, a little bit of accumulation in Pennsylvania, the higher elevations, and even in parts of western North Carolina. There could be some snow. And that's something that we're watching very, very closely, but just wanted to let you know about that situation because As this front comes through, it's going to change the wind direction to the northwest, and then it's going to drop the temperature and strong winds behind it. You can see these are almost like strong winds punching in behind this front. So that is the update as far as we're concerned today, and I'm going to give another update during the day tomorrow. We've had some internet glitches here during the day today. So hopefully tomorrow things will work out. I can show a little bit more information. But thanks for watching this update. This is for the All Hazards Consortium Sensitive Information Sharing Environment. And we'll be back tomorrow, hopefully between about noon and 4 p.m. Eastern Time. We have another atmospheric river that's going to be developing after this first one on the West Coast. We'll be monitoring it and bringing you all the latest information. Thanks for watching. We'll see you tomorrow.